Good evening. Hi, good evening. Am I audible? Hi, good evening. Am I audible? Please give me thumbs if I am audible. Hello? Am I audible? Hello, am I audible, my dears? Audible? Yes. Hello? Okay. So, good evening once again. Welcome to Go Score Learning. We are the fastest growing edtech in GCC. Our aim is to provide education for all. So, myself, Rahul Raj from Physics Department of Go Score Learning. So, here, as you have seen in the thumbnail, so I am going to discuss the most important questions from the chapters of grade 10 physics, which are electricity and magnetic effects of electric current. So, like this is a pre-board special live exclusively for some like DPS, United Indian School, Gulf Indian School, ICSK, Commerce School, Aspire Indian School, uh, Carmel School, etc. Okay, so I know these kids are having pre-board exam. Like most of them have pre-board exam like tomorrow, which is on 12th of January, and I think some of the rest of the kids are having pre-board exam in next week. Okay, so I think this live will be really helpful for you. So the teachers from GoScore have exclusively prepared this live for you. Okay, so you should make use of this YouTube live, and you should ask your friends to watch this YouTube live. Like definitely it will be help for them. So you do one thing, you take your WhatsApp and share this YouTube live link with every one of your friends. Okay, so that will be a great support for us. Okay, so let's get started. Okay, so we are working on a particular aim which is going to happen on 20th of February, Thursday, 2025, February 20, which is Thursday, our science exam, right? Okay, so I know most of my kids have covered all the important chapters, and now you are rush up with the boosting your knowledge by practicing more question, right? So this live is quite different from the previous physics live. So the previous live, what we have did is we have discussed the theory part as well, but here now it's a time to solve more questions, right? So here I'll be bringing you most important question from these chapters. Okay, so we can practice those. Or I don't want to tell like any other things. We can directly move to the part. Okay, so as you might know, there are 4 chapters, and today we are going to deal with the 2 chapters. Sorry, 1 second. Yeah, electricity and magnetic effect of electric current. From these 2 chapters you will be getting 13 marks. From these 2 chapters you will be getting 13 marks out of 25 in physics. Okay, so 13 marks questions are going to be asked in these chapters. Okay, done. So we can proceed with the question directly. We are moving to the question, and before that, like these are the topics that we have in electricity chapter. Okay, that you might already know. Okay, so we can see the couple of questions in from the all of this topic. Okay, so please follow the lesson, and please, if my audio is clear, then please show some thumbs in the comment box. That will be okay indicator for me. Okay, so today I will not spend more time in each question. I'll be like a quick revise the concept behind the question, and I'll be usually my lectures. Those who are watching my lectures already know. Like I used to spend more time on explaining the question, right? So today, as we need to discuss more question, I don't want to spend more time on the particular question. I'll be discussing the important point and important concept behind it, and we'll be solving the questions. Okay. Then. So state SI unit of electric current, define 1 ampere electric current. Actually, from the question itself, we'll be getting the answer for the first one. SI unit of electric current is ampere. You already know. Ampere. SI unit of electric current is ampere. SI unit of electric current is ampere. Okay. And other than that, okay, listen, define 1 ampere electric current. Okay, you might have seen this kind of question in most of the chapters, most of the topic in electricity. Define 1 volt potential difference, define 1 volt 1 watt of work, define so and so. Like, so I told you, like I have told my kids who is coming offline class in Gosco Center, like that if you got this kind of things, this kind of question, define 1 ampere or define 1 watt of power or define 1 joule of energy, like that, what we need to do is, here what is asked, electric current we need to define. Write the equation for electric current. I is equal to, what is the equation for it? Q by T. I is equal to Q by T. Okay, so then take Q equal to 1, T equal to 1, which means Q equal to 1 coulomb, T equal to 1 second. Okay, so then I become 1 coulomb per 1 second. 1 coulomb per 1 second. I become 1 coulomb per 1 second, which is 1 coulomb per second, which is 1 ampere. Okay, so this being the mathematical form, and now we can write the statement from this mathematical form. Okay, when 1 coulomb charge passes through the cross section of a conductor in 1 second, current is 1 ampere. When 1 coulomb of charge passes through the cross section of a conductor in 1 second, the current is 1 ampere. This is the thing. When 1 coulomb of charge passes through the cross section of conductor in 1 second, it can be given as 1 ampere current. Okay, so 1 coulomb per second is 1 ampere current. Okay, so this is how you need to define from the equation. You need to substitute all the values which is correspondingly as 1 unit. 1 here, charge and time is the quantity, so you can write 1 coulomb and 1 second. So 1 coulomb per second is 1 current. Sorry, 1 ampere current. Okay, so how do you define it? Electric current through a conductor is said to be 1 ampere if 1 coulomb of charge, electric charge, flows through the closed section of a conductor in 1 second. 1 coulomb charge flows through the closed section of a conductor in 1 second. That is what is 1 ampere electric current. Okay, how do you define 1 volt electrical potential then? 1 volt electrical potential. Okay, let us take like 1 volt is pretty easy. Like let us take 1 1 watt power. Define 1 watt power. So you know that power is equal to energy by time. Energy by time or work by time. So here we are dealing with electrical energy, right? So electrical energy. So rate of consuming electrical energy is power. So take E equal to 1, T equal to 1. What is E equal to 1 means? E is equal to 1 joule, T is equal to 1 second. So 1 joule per second, 1 joule per 1 second is called 1 watt. 1 joule per second, 1 joule divided by 1 second is called 1 watt power, right? So when 1 joule of work is done in 1 second, the power is said to be 1 watt. That's it. So this is how you can create the definition. It's just not all about, remember, I repeat every time, like, okay, so to define this particular 1 ampere, 1 watt, 1 volt, 1 coulomb, like that, you get the definition from the equation. It's not about by hearting things. It's not about by hearting things, viewers. It's not about by hearting things from the equation. So you should have good practice with that. Like from the equation itself, we can create it. Like here, we need to modify the statement according to the situation. So when 1 joule of work is done in 1 second, 1 watt power. That's it. Okay, at least you write this equation. Okay, if you are not able to write writing the definition or writing the exact definition in the exam, at least you write 1 joule per second is 1 watt. Okay, so at least you will get half marks. Okay, if you are not able to write the exact definition, it's maximum you try to learn the definition from the equation. Okay, don't by heart it. If you are going to by heart physics, nothing is going to be work for you. Okay, you'll be like trouble with the concept, like a high end question or conceptual question, you'll be trouble with that. So don't by heart physics. You need to by heart some of the things, but other things like definition, some laws, you need to by heart. But anyway, for this kind of things, it's not about by heart and things, it's about understanding the concept. Okay, next question, define electrical potential. Wow, so again defining electrical potential. State the relation between work W, charge Q, and electric potential V. What is the SI unit of electric potential? What is SI unit of electric potential? Those who answer, please comment. Yeah, Nihal is saying like yes sir. For which question I don't know, like for which question you have answered yes sir. Okay, so my grade 10 kids, please comment like what is that. If you know the answer for this particular question, it will be better if you are commenting. It will be like a booster for me. Okay, it will be like making me happy. Okay, so please comment. Okay, requesting you, if you know the answer, please comment out. Okay, define 1 volt electric potential. How do you define 1 volt electric potential? When you know that 1 volt or electric potential is equal to work by charge. This is a relation. So here there is a second question. Relation between W, Q and V. Potential is equal to work by charge. Potential is equal to work by charge. Potential is equal to work by charge. This is a relation. This is the relation for it. Okay. Potential is equal to work by charge. Okay. Potential is equal to work by charge. From the equation, you can define electric potential. Okay. So the amount of work done in bringing a unit positive charge from one point to another is called electric potential. Okay. So here it. The electric potential as a point is the defined as the work done in moving a unit positive charge from infinity to that point or one point. So here potential difference is from one point to another. If you are defining electric potential at a point, you should define in such a way that the amount of work done in bringing a unit positive charge from infinity to that point. That's a potential. Okay, so amount of work done in bringing unit positive charge from infinity to a particular point is called as electric potential at that point, and the relation is V is equal to W by Q and SI unit is volt, as you already know. Okay, SI unit is volt. Okay, so you can expect for all of the terms that you are learning in this chapter electricity especially, you can expect this kind of question. Define resistance, write the relation between resistance, voltage, current, like that, one relationship, and after that defining the SI unit. Okay, so which means you need to have the clear cut idea about all the terms. I know that there are so many terms that you're dealing for the first time in your science subject which comes in this chapter. Okay, there are a couple of terms. Okay, so for them you need to by heart the definition, or either you like you need to understand the concept, and from that concept also you can like get the definition. It's not like write the same thing whatever is given in the textbook. You can like necessary changes. Okay, so the slight changes from without modifying the concept will be avoided with the mark. Okay, don't worry about it. It's not about by hearting everything. Like if the concept is there, you'll be getting still mark, but it's not about writing your own definition. You should write the definition accordingly. Okay, okay, proceed. Can I proceed? Yes. Okay, yeah. So Nihal have answered for the previous question, like not previous question. SI unit of potential is volt. Okay, great, correct, Nihal. Okay, then okay, so sorry for it. Okay, so next question. An electric kettle consumes 1 kW. So don't read, my kids, always I am saying in the question is, even though it is given as 1 kW, as we are physics students, especially my students, don't read it as kW. You should read it as kilowatt. You should read it as kilowatt. Okay, 1 kilowatt. Electric kettle consume kilowatt electric power. When operated at 220 volt, the minimum rating of the fuse wire to be used for it is, is there anyone who can give the equation which is supposed to be used over here to answer the question? Okay, what is the equation supposed to be used here? Okay, so here power is given. Power is equal to, let me change the color. Okay, I don't think like blue will be a perfect color for the question. Okay, we can highlighting things using blue. Okay, we can use yellow or white. Okay, this time white. Okay, so power is equal to 1 kilowatt. You know that kilowatt is not a SI unit. You should convert into SI unit, which is watt. Is equal to 1000. 1 kilo means 1000 watt. 1 kilometer is 1000 meter. 1 kilo ohm is 1000 ohm. Like that. Okay, kilo means 1000. Okay, power is equal to 1000. Operated V is equal to 220 volt. That is given in SI unit only. Okay, what do you need to find? The rating of the fuse wire. Rating of the fuse wire. So we need to check about the current. Okay, current. Need to check about the current. Depending on what current only, the fuse wire will be rated, right? Okay, fine. What's the relation connecting them? PVI. What is the relation connecting? Yeah, direct equation. Is there any comment over there? What's the equation connecting them? What's the equation connecting them? P is equal to, yeah, P is equal to VI. P is equal to VI. P is equal to VI. What do you need to find? Current, right? So adjust it, adjust it. So I is equal to I is equal to P by P by, which is equal to, what is P? Yeah, 1000 divided by 220. So 2 cancel, 100 by 22. 100 by 22, after calculation you'll be getting 100 by 22. If it is 100 by 20, it is like 5. Here after the calculation 100 by 22 you'll be getting 4.5 ampere. No, it is 4.5 ampere. Okay. So but 4.5 is not there in the answer. 4. Is there any something mistake with my answer? Is it? What's the mistake with my answer? Look at the question. It is not for finding the current. The minimum rating of the fuse wire, minimum rating of the fuse wire that you are supposed to be used for the circuit. Okay, so fuse wire is a safety device. It's a safety device. So it will melt. It is the working principle of fuse wire is heating out of electric current, that you already know. Okay, so it will melt when a current more than its rated value have passed through it. Okay, imagine a fuse wire has 2 ampere as a rated value, which means up to 2 ampere current it can withstand. If a current of 2.3 ampere flows through it, it will melt. It will melt. Okay, so here the circuit, this particular circuit is handling 4.5 ampere current. Okay, so if you are used 4 ampere range or 4 ampere rated fuse, when 4.5 ampere current is falling through or flowing through it, it will melt. So you need to move to the nearest value which is higher than that. Okay, nearest value which is higher than that is 5 ampere. So 5 ampere is the right answer. So this is how you can choose the rating of the fuse wire. Okay, so common question. Okay, got it? Got it? Yeah. Then next one. In a circuit diagram shown, the two resistance wires A and B are of same area of cross section and same material, but A is longer than B. Which ammeter A1 and A2 will indicate the reading of the current? Give reason. Okay, so here ammeter reading means current. Ammeter reading means is a measure of current, right? So out of A and B, which is giving more current? That is the question, right? Which ammeter will be indicating the higher reading? Okay, which is having higher reading. Okay, which will be having higher current. Okay, so here which topic? Factors on which electric current depend. Factors on which electric current depend, that is the topic, right? Factors on which electric current depend, that is the topic. Okay, what are the factors on which electric current depend? I have given you a code. What was the code? Is there anyone who can remember the code for factors affecting electric current? Our code was LANT. LANT is the code. LANT is the code. What is LANT stands for? What is LANT stands for? Okay, give me. Okay, Nihal, I think you can answer this question. What is LANT stands for? L for length, area of cross section, nature of the wire, T for temperature. Length, area, nature of the wire, and temperature. So here A and B are of same material. So A and B are of same material means we can neglect about nature of the material. Okay, so here no need to consider the temperature, because temperature related temperature and variation of resistance in grade 10 you are not at all dealing with anything. Okay, so we can deal with that once you are in grade 12 physics. Okay, don't worry, we'll be dealing with that. Okay, related temperature. So here we'll be dealing with length and area. Okay, so what they have mentioned is same cross sectional area. So cross sectional area will not be a factor over there. So only we need to consider about length. So it has A has larger length. So length of LA greater than LB, length of B. Okay, as you know, resistance is directly proportional to length. So A will be having more resistance. A will be having more resistance. A will be having more resistance because A is longer. A is longer than B. A is longer than B. So resistance of A more, B less. Resistance is more, resistance is less. Okay, you know that. What you need to find here, the question is not for which is having more resistance. The question is for which ammeter will be giving more reading, higher reading. So you know that I is inversely proportional to resistance. I is equal to V by R. You know the Ohm's law triangle, right? Ohm's law triangle, V I R. V equal to IR, I equal to V by R equal to V by I, R equal to V by I. Like that, you cover the topic, cover the thing which you need. V equal to I into R, I equal to V by R. R equal to V by I, like that. So I is equal to V by R. So when resistance here, A has more resistance, so current is less, but B has less resistance, so current is more. So here current will be more here. Current will be more in the case of B. So ammeter A2 will be showing more reading. Ammeter A will be showing more reading. So give reason. So give reason is what I said right now. Okay. So here both the material, both the resistors are have made up of same material. They have same area of cross section. So the resistance will be depend only on length of the material. So here in this case, okay, only on length of the material. Okay, and length is more for A. A has more length, as we know, resistance is directly proportional to length. More the length, more the resistance. So resistance, A has more resistance. A has more resistance, so the current will be there is less, and current will be there in B because it has less resistance. Current will be more, so A2 will be showing more. That's it. It's a 2-mark question. Okay, got it? Clear? Clear? Yes. 1 second. Yeah. Okay, it's already given out there. Okay, you can check it. Second question. Okay, it's related to VI graph. Okay, so my kids, please answer the question. Slope of VI graph. Slope of VI graphs gives. Slope of VI graphs gives resistance. Slope of VI graph gives resistance. Okay, so in which V is plotted on x-axis or y-axis. Okay, slope of VI graph gives resistance, and when V is plotted here in y-axis and I is plotted in x-axis, the slope, okay, so the slope is resistance, but here look at the equation. So here a student plot VI graph which is mentioned, a student plot VI graph which is mentioned, leave it. It's not about whether the what is the name given in the question. Look at the graph. Look at the graph here. I is plotted in y-axis and x is plotted, sorry, V is plotted in x-axis. So here, what is the slope? What is the slope of this graph? Slope of this graph. Can anyone comment for this? Can anyone comment for the slope of this graph? Which one is the slope of this graph? Which one is the slope of this graph? Slope. Slope of this graph is not R, it is 1 by R. Why? Because slope means, I repeat, slope means quantity on y-axis divided by quantity on x-axis. Slope means quantity on y-axis divided by quantity on x-axis. Yeah, Vinci Ajesh. I don't know who is answering from that. I think the mother name is Vinci. Okay, so V is on y-axis. So V should be supposed to be on y-axis, but here it is like given like inverted. Okay, so here what is the quantity on y-axis? Here it is current, and what is the quantity on x-axis is voltage. So I by V, what do we know is V by I equal to resistance R, but here it is I by V, what we want. So it is reciprocal of that one. So I by V means it is 1 by R. So here slope is giving nothing but reciprocal of resistance. So slope of a graph which is plotted in which I is on y-axis and V is on x-axis is 1 by R. Is 1 by R. Okay, so here slope is more for R3. Just have more slope, right? And slope is less for R2. Slope is less for R2. Slope is less. 1 second, 1 second, 1 second. Okay, slope is less for R2. More slope. So here more slope means 1 by, more slope is here for R3. So 1 by R is more for here. So here 1 by R is less for this one. Okay, so 1 by R is less means 1 by R is less means, okay, so listen, 1 by R is more, slope is more means 1 by R is more, 1 by R is more means R is less. So here I'll be better to write it like here, slope of R3 is more. Slope of R3 is more and slope of R2 is less. But as it is 1 by R, you just take the reciprocal, just take the reverse of that one, which means R2 will be more, resistance R2 will be more. Resistance R2 will be more because it has least slope. In the case of, you just directly think about it like if it is I on y axis and V on x-axis, you should be taking like which is having least slope will be having more resistance. Is having least slope will be having more resistance. If it is B plotted here and I plotted here, is having more slope, you will be having more resistance. So, but here, unfortunately, not unfortunately, a question I have given like the slope I on y-axis and V on x-axis. Okay, got it. So here, which is having least slope will be having more resistance. So R2 is more than second one is R1. R1 is more than R3. Okay, R2 more than R1 than R3. Option the last one. Okay, so this is the answer. This is the answer for this question. This is the answer. Okay, done. Okay, okay. Yes. Okay, so will the current flow more easily through the thick wire or thin wire of the same material when connected to the same source? Okay, so we have a thick wire. Okay, I have a thick wire. 1 second. Let us take it like. Okay, I have a thin wire and a thick wire. Thin wire and a thick wire. So whether will current flow more easily through thick wire? More current flow more easily means resistance is less. Okay, so whether it thick wire or thin wire, you know that like imagine a flow of water through it. Through this which pipe the water will flow easily, whether the thick one or the thin one. You know that water will be flowing easily through the thicker one, right? So same as current. The same thing is there for the current flow. Current is also already a flow, right? Okay, so current will be flow easily through thick wire. So because you know that R is equal to rho L by A, which is R is inversely proportional to area of cross section. If more the area, less the resistance. So here more the area of cross section, right? More the area of cross section, less the resistance. So it is easy for the current to flow. It is easy for the if resistance is less. Resistance is what? What is resistance? How do you define resistance? The opposition offered by the flow of electric current to a wire or through a conductor is known as resistance, isn't it? So if A is more, R is less. So thickness is more, resistance will be less. So the current will flow more easily through a thicker wire. Is there another question when connected to same? Okay, same question. Way means this is the answer. This is the answer. As resistance is inversely proportional to area of cross section, as thick wire area cross section is more, so resistance will be less. That's it. Okay, got it. This one. Yeah, answer is also given over there. Okay, it's fine. Completely fine. Okay. No, VA graph to conducting wires A and B are shown in the figure. If both wires are of same length and same diameter, the same diameter means same area of cross section. So length is same, area of cross section is also same. Length is same, area of cross section is also same. Which of the two is made of material of higher resistivity? Okay, so here it is. Comment me, like comment on the let's comment on the comment box, like which is having VA graph. So out of B and A, which is having more resistance. Okay, which is having more resistance. So you know that VA graph, it is not IV graph. No, it's not like you find to say like IV graph, VA graph. So here V is on y-axis and I is on x-axis. So slope of this graph is resistance. VI. So slope of this graph is resistance. So here slope is more for RB. So we can write RB more than RA. RB is more than RA. Resistance of B is more than resistance of A. Resistance of B is more than resistance of A. So L and A is same for everything. So the other quantity which is depend on resistance is resistivity rho. Resistivity rho. Okay, you know that R is proportional to resistivity. Resistivity more, resistance will be also more. Okay, R is proportional to resistivity. Or resistivity is more means resistance also we can take is increased. Resistivity increased, resistance also will be increased. Okay, so RB is having more resistance. So rho B, resistance of B should be more than resistance of A. Resistance of B should be more than resistance of A. Give reason to justify your answer. This is justification. So here B will be having more resistivity. Reason in the graph, slope is more for B. Okay, you should write like that. Okay, it's not about writing this much of things on the board. As I need to discuss more questions, that's why I am skipping the writing part. But I have explained, right? So whatever things I have given, you should whatever things I am saying, you should write in the paper. Okay, you should write in the paper. Okay, so here RB greater than RA. So resistance of B will be also greater than RA, because resistivity increases, resistance also increases. That's it. Okay, fine. Yes. What is electrical resistivity? Remember, it's not what is electrical resistance. It is asked about electrical resistivity. Resistivity and resistance, they are like different entities, different quantities. We can't define both of the quantities as like as such, not as like same. It will be different definition. Resistance, the opposition given by the flow of electric current to the conductor is known as resistance. But resistivity, how you define means resistivity equation. What is the equation for resistivity? uh, resistance is equal to rho L by A. So rho is equal to R A by L. If A equal to 1 meter square and L is equal to 1 meter, you can take it like rho is equal to R into 1 meter square by 1 meter. Okay, so you'll be getting rho equal to R. Rho equal to R. When you are taking a conductor of unit area of cross section and unit length, it is resistance is equal to resistivity. Okay, so we can modify the statement. Resistivity is the resistance of the material. Resistivity is equal to resistance of the material. Resistivity is the resistance of a material, or resistivity of a conductor which has unit length and unit area of cross section. Unit length means 1 meter length. Unit area of cross section means 1 meter square area of cross section. And that's it. Resistivity is the resistance of a conductor which has unit length and unit area of cross section, and that's it. Got it? Okay. And SI unit is there anyone can comment the answer for this one? SI unit is ohm meter or omega meter, you can write, but you should read it as ohm meter. SI unit is ohm meter. SI unit is ohm meter. SI unit of resistance is ohm meter. SI unit of resistance is ohm. Done. Okay, then what is, the answer is over here. Okay, electric iron consumes energy at a rate of 880 watt when heating is at the maximum rate, and 330 watt when the heating is at minimum. If the source voltage is 220 volt, calculate the current and resistance is gauge. Okay, so by reading the question like a complicated question, you do one thing, you just write the things which is given over there, like power. Power is given. Power is equal to P1. There are two powers is given, so we can take it like P1, 880 watt. Okay, voltage is also given. V is equal to 220 volt. 220 volt is equal to 220 volt. What do we need to calculate? What we need to calculate is current. Current we need to calculate. Then resistance we need to calculate resistance. What is the relation between P, V, and I? We have P is equal to Vi. So I is equal to P by V is equal to power is 880 divided by V is 220, 2 cancel. So 804, 4 ampere. Done. That's it. So in every numerical, you should approach like this. You should write the given details and you should search for what is the quantity which is to be find. Then find the not finding the relation. You should check about the relation which is connecting them and write the relation, adjust it, and find the answer. That's it. How easy? This is how like physics become easy. It's not about by heart things. How can you by heart like this kind of numericals? How can you by heart the steps which is involved in this kind of numericals? That is not possible. So adapt the method. That I am saying. What is the method? What is the method to be followed? Write the given things. Write the quantity which is to be found, which is to be find. Okay, which is to be find. You should write. Then connect the equation. Like write the equation which is connecting them. You should by heart the equation. You should have the idea about the equation that you should supposed to use. Then you can write it. That's it. Okay. Okay, clear. Then I you have find. Then we need to find, right? So what is the relation? Sorry, resistance we need to find. So what is the relation connecting P, V, and R? You know that P is equal to V square by R. P is equal to V square by R. So which is equal to V square means 220. Okay, let us connect it like R, which implies R is equal to V square by P, which is equal to 220 into 220 divided by 880, 0, cancelled, which is equal to 220 into 22 divided by 88. So cancelled 4 times. Okay, so now you can calculate 220 by 4. 220 by 4. 220 by 4 is the answer. 220 by 4 ohm. So what is 220 by 4? 110, 110, 55. 55, yeah, 55 is the answer. 55 is the answer for the question. So 55 ohm. 55 ohm. That's it. The answer is 55 ohm. Repeat the same for the same method you can adapt. The same method you can adapt for the second question, because here only power changes. V remains same. V remains same. Only power changes. Instead of 880, you can substitute 330 and follow the same method. Follow the same method and we'll be getting these values. Okay. So just look at the equation. Look at the equation that you have got. In the second case, for what is the power? And what is given over there? 330. I think there's a mistake. It should be 440. 440 watt, then only the calculation will be smooth. Okay, 440 watt, 440 watt, and current will be getting 2 ampere, and resistance will be 110. That's it. Okay. Okay, same method you can, the same method that I have followed, you can adopt for the second thing. That's it. Same question. Okay. So I'm moving to the next question. Okay, if you find any difficulty regarding any particular question, you just let me know. I'll explain that once again. Okay, so there are three resistors of 10 ohm, 20 ohm, and 30 ohm joined in parallel in a circuit. The potential difference across the electric circuit is 10 volt. Draw the circuit diagram for the above case. Draw the circuit diagram for the above case means, okay, three resistors, right? Connected in parallel, joined in parallel. Three resistors connected in parallel. Okay, so what are the resistors? 10 ohm, 20 ohm, 30 ohm. It's connected to 10 volt supply. So we can connect a battery of 10 volt. So this is the circuit diagram. That's it. Connecting them parallel. Okay. So this is done. Find the total resistance of the combinations of the resistors. So we are going to find the total resistance of the combination. We know that is a parallel combination. There are three resistors. We need to use the formula 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. What is 1 by R1? 110 plus 1 by R2 20 plus 1 by 30. That's it. Okay. So which is equal to, we can use the LCM like 10, 20, 30. What is LCM? What is LCM? Those who are like max students, all of you are max students, right? It's not about grade 12 here. All of you are going to write max exam. So all of the students who is sitting and watching this live are max students. Okay, so LCM is 60. So 60 means 6 by 60. 1 by 10 means 6 by 60. Okay, plus 3 by 60. 20 into 3 is 60. So 3 by 60 plus 1 into 2. So 2 by 30 into 2 is 60. So 2 by 60. So the denominator becomes same. So it is 6 plus 3, 9, 9 plus 2, 11. So 11 by 60 it is. 11 by 60. That is 1 by Rp. Okay. Don't write resultant, effective resistance equal to 1 by 11 by 60. Not that, that is 1 by Rp only. So therefore Rp is equal to 60 by 11. 60 by 11. Okay. What is 60 by 11? 60 by 11 is like, you will calculate it. Okay. Calculation 60 by 11. So is there anyone who is like, you can calculate it easily, more easily than me? Okay, so 60 by 11, how many times? 5 times, 55, 55, 55 is remaining 5, so 50 again, 55 4 times, so 44, so 44 then remaining 6, 60, 60 again 5 times. Okay, it will be going so. Okay, so you can take like 5.45 resistance, right? 45, oh, 4.5, oh. 4, 5. Oh, that's it. So that's the resultant resistor. Calculate the electric current drawn from the main source. Electric current drawn from the main source means uh, I is equal to V by R. Okay, before that you should name the answers. Okay, this is for option A. Sorry, question A. This is question B, and this is for question C. And after getting this RP is equal to 5.45 ohm, you should write the effective resistance of the combination is, I think XYY answered it is 4.5.45. I don't know like who is SYYY. Okay, who was that? Okay, Nihal. Okay, Nihal also commented is 5.45. Okay, so can you comment the current value? That will be better. Current value. I is equal to V by R. I is equal to V by, so it is V by RP. This is equal to 10 by, what is RP here? What you have got? 5.45. Okay, you calculate it and you put in the comment box. Okay. Meanwhile, I am saying something, not something related to this only. So if you got RP is equal to 60 by 11, which is equal to 5.45 O, you should separately write the total resistance of the combination is 5.45 ohm. You should write it in the paper. You should write in the paper. Okay. Meanwhile, I didn't get the answer for this question calculation. Please, anyone please help me. Anyone please help me. No one is there. Nihal, XYY, no, who is XYY? Vinci, not Vinci, it is, I think it is her, his mother or her mother account. Okay, like, please comment your answer. Please comment your answer in the comment box. Okay, no one is there. So 10 by 5 per is like 1 point, I think it is 1.8 ampere, almost 1.8 ampere. Yeah. Nihal have answered. Yes, Nihal have answered. It is 1.83. Okay, good job, Nihal. What I have got? Okay, I'll correct it. 1.83. 1.83 ampere. Okay, good job. I mind calculate like it is 1.8, almost 1.8. Okay. Okay, Nihal. Okay, Nihal. Great job. Okay, that is done. Then, okay. So it's almost okay. 45 minutes covered. Okay. So take Joule's law. I don't want to state the Joule's law that you already know. What is Joule's law of heating? Joule's law of heating state that the electric current, sorry, the heat energy produced by a current carrying conductor is directly proportional to square of the current. It is directly proportional to resistance of the wire, and this is directly proportional to time for which current is flowing. Okay, it is directly proportional to time for which current is flowing, and you should write in the matter. This is mathematical form. You should write in the words. You should write the words. Okay, and express it mathematically when an appliance of resistance. Resistant. Okay, fine. Is connected to the source voltage V, and V is also involved here. Okay, and the current I flows through the appliance for a time t. So all the quantities, resistance is mentioned, V is mentioned, I is mentioned, T is mentioned. Okay, so as mathematical form of Joule's law is I square T. As potential difference, V is also mentioned over here. Better to write, which is equal to, you know that V square by R into T is also equal to, you can write H is equal to, same again, H is equal to, as I also mentioned here, V I T. Okay, you can write all the equation, that will be better. Mathematical form, you can express, you can give all the forms. Mathematical thing, mathematical expression, you can write all of this. Okay, that will be much better. Okay, as every quantity is mentioned over there, you can read it. Okay, so this answer over here, yeah, answer also given over here. So here I will be adding one more answer, which is equal to V square by R into T. That's it. Okay, okay, yes, got it. Okay, now next question. The resistance of the wire, a wire of 0.01 centimeter of radius is 10 ohm. The resistivity of the wire is 50 into 10 to the minus 2 meter. Find the length of this wire. Okay, which equation? My kids, please give the equation which is supposed to be used. Which is supposed to be used? Which equation? Okay, I know that you may be suffering to type the raw value in the keyboard. Okay, anyway, I'll write here. You know that R is equal to rho L by A. Rho L by A. What do we need to find is L only, right? So L is equal to R into A by rho. So here, what are the given things? What are the given things? L, oh, L we need to find. L we need to find. So resistivity is given. Resistivity is equal to 50 into 10 raised to minus 2 ohm. Oh, here unit is missed. This ohm meter. Okay, so pardon me. Okay, not for giving ohm meter over there. Being a physics teacher, I should write accordingly, right? Proper thing, right? So rho is equal to R A by L. Yeah, good, very good job. Who's that? CB Jacob. I think it is Joel. Who was that? Coming from the CB Jacob account. Who was that? Please provide your name. That will be better for me. It will be making me happy. Who was that? Is John or Joel? Who was that? Oh, I is equal to R A by L equal to R A by rho. Okay, fine. Very good job. Very good job. Okay, so who have come from CB Jacob? Let me know. Okay, let it be. Let it be. Okay, so I didn't provide the ohm meter over there. Okay, pardon me. Pardon me. Okay, fine. Okay, so rho is equal to 15 to 10 minus ohm meter. It's not ohm meter. Okay, then yeah, resistance. Sorry, radius. R is given. R is given as 0. 0.01 centimeter. I have seen some of my kids have make the mistake. Yeah, Joel. Okay, good job. I got it. Okay, so I have seen some of my kids have taken this one as area. Listen, my kids. Look at this given as a radius only, right? This is not area. You need to find area as pi r square. So you need to convert in centimeter into meters. Converting centimeter into meter means 0.01 divided by 100. That much of meter. Okay, cendi. Cendi means dividing by 100, or in mathematical language it is 10 raised to minus 2. Centimeter is 10 raised to minus 2 meter. Millimeter is 10 raised to minus 3 meter. Got it? Okay. So 10 raised to minus 2 meter and 10 raised to minus 3 meter for millimeter. Centimeter 10 raised to minus 2 meter. So one with two zeros. Okay. Okay. So pi r square, which is equal to 3.14 into 3.14 into 0.01 divided by 100 whole square is equal to 3.14 into 0.01 square means 0.0001 divided by 10,000, 1 with 4 zeros, which is equal to, okay, 3.14 into 0.0000, okay, let me take it like into 10 to the power 4, which is coming to the numerator 10 raised to minus 4. So I'll write it like 3.14 into 1, 2, 3, 4. So 1 into 10 to the power minus 4. 1 into 10 to the power minus 4 into 10 to the power minus 4. So I'll be getting, okay, I'll be getting, it is equal to 3.14 into 10 to the power minus 8 meter square. Great. You need to find, it is not, radius is given, it is not area of cross section. So you need to find it. You need to find it. Okay. So you need to find it. Okay. So R, what is R given? Now we can move directly into the question. 10 no. Okay, rest of things are given only. Okay. So 10 into what is area? 3.14 into 10 raised to minus 8 divided by 50 into 10 raised to minus 2. Minus 2 or minus 8, what is given over there? It was minus 8 only, okay. Again, typing mistake from my side. Pardon me, pardon me. Okay. Minus 8 only. Okay. So minus 8 again here. So minus 8 cancelled. Okay, which is equal to again here 0 cancelled. So 3.14 divided by 5 it is. 3.14 divided by 5. That is the first answer. 3.14 divided by 5. So is there anyone who can answer this one? 3.14 by 5. 3.14 by 5. Is there anyone? Is there anyone who can answer this one? 3.14. Where is like Joel, Nihal, XYY? Who is XYY? I don't know. Like, answer the question. Okay, if you are not over there, I'll be giving like 0.628 meter, I think. Okay, I had did it before. That's why I'm like, in exam you are not supposed to write like this. You should calculate. Okay, as I have did this question before, like from my memory only. Yeah, it's 0.628 meter only. 0.628 meters. Okay, that's it. Okay, it is 7:50. Yeah, need to hurry up. So there are, I think I have covered only half of the question. Yeah, Nihal have answered 0.628. Nihal, it should have the proper unit. So answer with proper unit only you'll be getting mark. If you didn't got the unit, you'll be lose half mark. Okay. So find the equivalent distance of arm C. I am moving directly to the question. Okay. One second. Let me drink some water. Okay. Thank you. Sorry. Okay. Anyway. Okay, find the equivalent distance of arm C. Arm C means 10 ohm, 20 ohm, 30 ohm. They are contained series. So 10 plus 20 plus 30. What is it? 10 plus 20 plus 30, 10 plus 20 plus 30, 10 plus 20 plus 30. Okay, what is it? 10 plus 20 plus 30. Okay, 60 ohm. So answer for this 60 ohm. 60 ohm. 60 ohm. Yeah, meter. He have counted with the option. Unit also he have counted. Okay, great job. Great job. Okay, so 60. Now you can answer this question also. Calculate the equivalent resistance of the parallel combination of the arm B and C. Parallel combination of the arm B and C. Okay, so here 10 plus 20 plus 30, it has 60 ohm, and the other one is 5 plus 10 plus 15. So 15 plus 15 is 30 ohm. So not 30, 30 ohm. So these 30 ohm and 60 ohm are connected in parallel. So I'll be directly moving to the answer. So parallel combination R, what is it like RB and C, right? So I'll be writing RBC. RBC. There are two resistance 30 and 60. They are concluded into, or we can confine into. 1 second, something is irritating me in my hand. Like what happened? Okay, okay. Okay, fine. Okay, so RBC, so there are two resistors connected in parallel. We can use the shortcut formula. When two resistors are connected in parallel, we can write the effective resistance are R1 R2 divided by R1 plus R2. R1 R2 divided by R1 plus R2. So here it is RB RC divided by not PC RC. Okay, RC. So RCB. Oh, not. Is there any RCB fans? Is there any RCB fans over here? King Holy fans? No. Okay, let it be. Okay, RB into RC, RB into RC divided by RB plus RC. RB plus RC, which is equal to what is RB? RB is 30 into 60 divided by 30 plus 60. 30 plus 60, isn't it? Is equal to 6 into 3 is 180. Sorry, 6 into 3 is 18. 18 with the double zeros divided by 9 zeros. 0 0 cancel. 80, 180 by 9. So 18 two times. So this 20 ohm. 20 ohm, quite easy. So how will you get like a question which is simpler than this one in from combination of resistors? Quite easy question, right? Okay, so determine the current flows through the ammeter. So now you have got, for finding the current flows through the ammeter, you should find the effective resistance of the circuit. You have got, this is 20 ohm, right? This is 20 ohm. So 20 ohm, now this 20 ohm is connected with, now this 20 ohm is connected with, this 20 ohm is connected with the series combination of 5 plus 15 plus 20. What is it? 5 plus 15 plus 20. So it is 5, 20, 20, 40, right? So 40 ohm. So now the effective resistance become RABC. RABC equal to RBC plus RA, because RBC you have got 20. So RA means it is 40. So 20 plus 40, which is equal to 60 ohm. So that is a total resistance, effective resistance of this combination. That is the effective resistance of this combination is 60 ohm. So what is the current we need to find? So we need I is equal to V divided by R ABC is equal to, what is V? V is 6 volt. So 6 divided by 60 is equal to 1 by 10. It's equal to 0.1 ampere. 0.1 ampere. That's it. 0.1 ampere. Okay, done. Fine. Okay. So yeah, is it readable? I think it is not. Okay. Anyway, like for identical resistors. Okay. Anyway, we can skip this question. It's not readable in the form of readable. Okay. Okay. Calculate the equivalent resistance of the following electric current. Sorry, electric circuit. Oh, again, pardon me. Okay, it is circuit. This electric circuit. Calculate the equivalent resistance of the following electric circuit. Equivalent resistance, how can we calculate? Okay, so I am like, in order to, I will be giving the method we need to be adapted for calculating this one. Okay, so here find out this. This is not a series combination. This is not a parallel combination. This is a combination of series and parallel. Okay, so here these two resistors are connected in series. So effective resistance is 20. Now this 20 ohm is connected in parallel with the other 20. So 20 and 20 connected in parallel. So here we can use the formula. When two identical resistors are connected in parallel, you can use the formula. Effective resistance of parallel combination is equal to R by N. What is R here? R here is each R 20. So 20 by 2 is equal to 10 ohm you will be getting. So effective resistance of this combination is 10 ohm. Effective resistance of this combination is 10 ohm. Okay, so 10 plus 10, 20. So 20 and 20 connected in parallel. So identical resistors connected in parallel. So resultant resistance is effective resistance is, you can use the formula R by N. You can use the formula R by N. So R by N means 20 by 2. So 10 ohm. Okay, no. So 10 ohm, 10 ohm is in series with this one and this one. So now you'll be getting effective resistance of the combination R effective is equal to 10 plus 10 plus 10, which is equal to 30. That's it. Okay, you should do it step by step. Okay, you should do it step by step, not like as I do over here, because I have did this only for getting maximum question in 1 hour. Okay, so in exam you should write it in detail, because each step have mark. In marking scheme, different step will be having like corresponding marks, like 0.5 or half mark or 1 mark will be given, even for writing the equation also. Okay, on substituting the values also there is mark. Okay, so that we already discussed in the class, and I have given you the sample of marking scheme I have shown to you, right? So in that I have clearly showed that, like for different steps, for writing the equation, for substituting the values, there are marks. Okay, if it is a 4 mark question, that 4 mark is not only for the last final answer that you are getting. For writing the equation in between, for substituting the values in between, for giving the unit properly, there are marks. Okay, so do it accordingly. Okay, okay. Okay, an electric heater rated as 1100 watt operated at 220 volt. Calculate the resistance and current drawn by it. We have did this question, same kind of question. So now I am not going to solve it. I just give the equation. Okay, so what are the given things? What are the given things? Okay, so power is equal to 100 watt, and potential difference V is equal to 220 volt. What do you need to find? Resistance we need to find, current we need to find. Resistance we need to find, current we need to find. What are the equations? So what are the equations? Is there anyone, Nihal, Joel, X and Y, like X, Y, not X and Y, S, Y, Y. Anyone? Just J with, what was the name? I forgot. Okay. Anyone? Is there anyone who can comment? Sorry. Who can comment over there? What are the equation? So P is equal to V square by R. So R is equal to V square by P. So it will be giving resistance R. Okay. So you know that P is equal to VI. So I is equal to P by V. So it will be giving current. So P and V is given over there, right? P and V is given over there. So you can find it. Okay, that's it. Okay, that's it. P is equal to V square by R. So we are going to get R as V square by P. Sorry. Yeah, P by V. Correct only. So you can did this. Okay, finish it. Okay, so now I think I need to move to the questions which is from the other chapter, which is magnetic effect of current. Let me see whether there is an important question that I have missed. Okay. Okay. This is one of the another kind. Okay. So a nichrome wire is given below. What do you infer from this graph? A VA graph of nichrome wire is given below. What do you infer from this graph? So this one also a kind of question which is asked. Okay. So this is VA graph, right? So it's giving a straight line. So what is the what inference that you are getting from this graph? What is the conclusion that you are drawing from this graph? So you know that VI graph, slope of potential difference versus current graph, is the resistance. So okay, so here when potential difference is increased, current also increased. So when you are increasing the potential difference across the nichrome wire, current also increasing. That is the first inference. Or you can also write like resistance of the nichrome wire is a constant at a particular temperature. At a certain temperature, at a constant temperature, resistance of a wire is constant. It will not be varied. So that is also conclusion that you are taking from this graph. Why? Because VA graph slope is resistance. So here R, the slope is same only, unique. It has a unique slope, which means straight line, right? So straight line always have a unique slope, same slope everywhere. So resistance is constant. As slope is constant, resistance is also constant. That is an inference that you are getting from the graph. Okay, so draw a labeled circuit diagram, obtain such graph. What is this labeled circuit diagram that you can draw for getting this graph? So you should connect the resistance. Should connect the resistance. Okay, you need to measure the current, you need to measure the potential difference. So we can measure the potential difference using across the resistor by connecting a voltmeter, and you can connect a series ammeter, and you can connect a battery. Okay, so you should change the battery voltage, so it should be varied thing. Okay, so V, it is R, it is voltmeter, it is ammeter, that's it. Okay, you can also attach a key, you can also give a key, that's it. This is a circuit diagram you should draw. Okay, done, got it? Okay, yeah, so the circuit diagram is also over there. Okay, okay, so this is the last question that I am going to solve from this chapter. Then I will be discussing couple of questions, few questions from the other chapters. Also we can find. Okay, maximum resistance which can be made using 4 resistors each of 2 ohm. Okay, so you know that maximum resistance is when the resistors are connected in series. Maximum resistance is when the resistors are connected in series. Maximum resistance is when the resistors are connected in series. Okay, so 4 resistors, sorry, 2 resistors, sorry, 4 resistors, each of resistance 2 ohm, connected in series. So connected in series only you will be getting maximum resistance. So when they are connected in series, R series is equal to, you know that, Rn, R into N, R is equal to here, N is equal to 4 here, which is equal to 8 ohm. So the maximum resistance that you are getting is 8 ohm. So 4 ohm, sorry, 2 ohm resistors, there are 4 resistors. So maximum resistance will be when they are connected in series. Minimum is then when they are connected in parallel. So for parallel combination, what is the formula for identical resistors? By N. So the minimum resistance that you are getting, that is not the question, but anyway I am explaining. The minimum resistance is when we are connected in, 8 ohm, correct. Go ahead and say, yeah, X and Y. Sorry, not X and Y, X, Y. Okay, so minimum resistance when they are connected in parallel. So 2 by 4, which is equal to 1 by 2. So 0.5 ohm. Minimum resistance. So you think like maximum resistance when they are connected in series, minimum resistance when they are connected in parallel. That's it. Okay, done. Okay, so yeah, moving to the next question, which is from moving charges and magnetism. Okay, so which rule for this kind of actually my kids doesn't need to read the question at all. When they got this kind of diagram, immediately after they will be finding the answer by using the which rule? Left hand thumb rule. Father, mother, child, force, magnetic field, current. Father, mother, child, left hand thumb rule. So F, father, force. M, mother, magnetic field. C, child, current. Okay, so current in which direction? Here it is positron, sir. I don't know what is positron. So positron is like a positive particle which is just having the opposite property of electron. Okay, positive charge is having positive charge. So if positron is moving in this direction, our current will be also in this direction. Current, the direction of current is same as that of the flow of positive charge. Okay, direction of current is same as that of the positive charge. So positive charge, positron moving upward. So current upward, magnetic field in this direction. So hold your palm like this, not palm, your hand, your fingers like this. So stretch them mutually perpendicular and hold like this. Magnetic field, current upward. Okay, so my thumb is moving into the page. Now I supposed to say into the plane, and what I have written over there is page. So it's got plage. Okay, pardon me. Okay, so into the page it is, into the page. That is into the page. Done. Okay, so which rule? Fleming's left hand rule. So could you please like for the exam, whoever is having exam tomorrow is, Nihal have answered. Fleming's left hand rule. Okay, next time when I am displaying question over here, you should come the answer. Right? If it is MCQ, you should rapidly answer for it. Okay, so Fleming left hand rule. State it. Stretch thumb, forefinger and index finger of your middle finger. In the forefinger and index finger are same work. Okay, thumb, index finger and middle finger of your left hand in mutually perpendicular direction if the middle finger shows the direction of current and the index finger shows the direction of magnetic field, then the stretched thumb will gives you the direction of magnetic force experience on the wire. Okay, so this is an usual question. You should able to write right hand thumb rule, which is used to find the direction of magnetic field by a straight conductor. Then this one is force experience on a current carrying wire, which is used to find by direction of force is used to find by Fleming's left hand rule. Okay, for the whoever is having exam tomorrow, please go through the statement. Okay, statement of this laws. Okay, fine. So middle finger is current. Middle finger is current. Yeah, correct only, Nihal. Yes. Yes. Okay. What does the degree of closeness of a field represent? What does degree of closeness of a field represent? Anyone? Anyone? Is there anyone who can comment the answer? Is there anyone who can comment the answer? Please. Nihal, Joel. Degree of closeness. Degree of closeness is a measure of. Degree of closeness is a measure of. Degree of closeness is a measure of. Okay, I'm waiting for your answer. Please comment. Okay, we need to wind up. Anyone? Okay, let me check the comment box. If they could comment it, I will not say the answer. Okay, you should check in the comment box. Okay, please. Yeah, I know. Okay, anyone? No. So far I didn't get any. Degree of closeness of field is represent. Oh, I disappointed. Oh, Nihal, don't make me disappointed. Joel, I don't know there. No, I think I should give the answer. Otherwise, it's a measure of strength. Degree of closeness of field lines represent the strength of the magnetic field. Degree of fieldness is a measure of strength of the magnetic field. That's it. Okay. And here I have given a figure. Okay. A and B, there are 2 points. A and B, in which region the magnetic field have more strength? In which region magnetic field have more strength? It is on A, because here field lines are more closer. Or it is a polar region, not earth polar region, pole of the magnet, north pole of the magnet. So out of A and B, A will be having more strength. That's it. Okay. So last question. Okay, last 2 questions for today. Last 2 questions for today. Okay, after that we'll be winding up the session. Okay, I know that I didn't discuss too many questions from this other chapter. Okay, don't worry. Those who have physics exam, which is the next week, we will be doing this. Okay, don't worry. Okay, so strength of a magnetic field of a current carrying solenoid is minimum at its ends, uniform inside all point, maximum at its center, zero at its center. So we can eliminate the wrong options. Zero at the center, wrong. Minimum at its end, that is also wrong. Uniform inside at all point, yeah, that is the correct one, right? You know that magnetic field inside a current carrying solenoid is uniform inside the solenoid. Okay, who answered it? Option A. A, what they said? A means minimum at its, no, uniform inside at all point. Inside the current carrying solenoid, magnetic field is uniform. It is clearly given in your textbook. Magnetic field is uniform inside the current carrying solenoid. Okay, so that is the answer. Uniform inside it all at all point. Okay, then which one of the last question for today, so that I'll be going to wind up. Okay, so yeah, answer the second question for here. Okay, which one of the following particle will not experience a force while moving perpendicular to uniform magnetic field? Okay, which one is that? Okay, answer for the question. Neutron, an alpha particle, electron, proton. Okay, let's starting from option D. Proton have a charge. So charged particle moving in a magnetic field experience a force, because charged particle movement is current. Okay, so proton will experience a force. Electron is a charge. Electron will experience a force. Alpha particle. What is alpha particle? Helium nucleus. Helium like nucleus is alpha particle with a positive charge. Alpha particle have positive charge. So all these 3 things are having charge. So it will experience, definitely will experience a force. Neutron, being it is electrically neutral, its movement is not a current. So it's not a current, so there is no force. Okay, so there will be no force for it. Okay, neutron is the right answer. Okay, done. Okay, so wishing you all the best, whoever is going to write the exam tomorrow. Okay, wishing you all the best, and don't worry the rest of the kids. Okay, those who have physics exam next week will be coming with a couple of live. Okay, goodbye, best wishes. Thank you.